Today we're looking at the reflexive, symmetric, and transitive properties of both figures and measures of angles. Figures, if I have two triangles that are exactly the same, I'm going to copy and paste this so that we have two triangles that are exactly the same. They are considered congruent. They are congruent triangles. Now measures, if I said that the measure of this angle here was 30 degrees and this one was also 30 degrees, the measure of angle A is going to be equal to the measure of angle B. If this is A and B, those would be equal measures, but the figures are going to be congruent. So measures are equal, figures are congruent. The next property we're going to talk about is the transitive property. And when I think of transitive, I think of a train. If we have a train that's going from A to B, and then the train goes from stop B to stop C, he really went from stop A to stop C. So what the transitive property says is if A equals B and B equals C, then A has to equal C. We have that common middle term. So remember, figures are congruent, measures are equal. So these properties of equality, they go with figures and measures. So if AB equals AB, remember it's reflexive. We're looking at a guy in the mirror. You're looking at yourself in a mirror, reflexive. If it's congruent, we have angle A, the figure is congruent to the figure. Like you could put them on top of each other. We would say A is congruent to A. Symmetric, we think of the butterfly. If A equals B, then B equals A. So if we look at that butterfly, this side is A, this side is B, we could just flip them around because they are equal. B equals A. Transitive is like the train. A equals B, B equals C, A has to equal C. Now you have to be careful. If I had have written this as B equals A and B equals C, A would still have to equal C because it has that common middle B term. So we could rewrite it as A equals B and B equals C. They have a common term. The B's would be common. So A would equal C. Let's review real quick these properties of equality. Addition property. If I had 2 was equal to 2, and I added the same number to both sides, I would get 6 equals 6. And notice those two numbers are still equal. If we add the same thing to something that's equal on both sides, it will still be equal. The same thing works for subtraction. If I start out with 8 equals 8 and I subtract 2 from both sides of the equal sign, I get something that is still equal. I get 6 equals 6. For the multiplication property of equality, if I start with 2 equals 2 and I multiply both sides by 3, 3 times 2 is 6 on both sides of the equal sign. 6 equals 6. It's something that is still equal. With the division property of equality, if I start with 12 equals 12 and I divide both sides by 2, 12 divided by 2 is 6. 6 would equal 6 on both sides of the equal sign. So we still have something that's equal. So if we divide both sides by a number, the same number, to something that's equal, you'll still have something that's equal. For the substitution property, if something is equal to something else, I can substitute it in for itself. So if I have x equals 3 and I'm trying to find out what x plus 2 is, I can substitute 3 in for x because they are equal. So I would have 3 plus 2 is equal to 5. If I have 4 plus 4, I could I could substitute 8 in anywhere there was a 4 plus 4, because 4 plus 4 is equal to 8. We could substitute them in interchangeably for each other. Okay, now we're going to just find the property that goes along with each statement. The measure of angle F equals the measure of angle G, and the measure of angle G equals the measure of angle F. This would be the symmetric property. One could go on both sides of that butterfly that we had. A would equal B, B would equal A. But in this case, we have measure of angle F and measure of angle G is equal to measure of angle G and the measure of angle F. So it's just the symmetric property. On number 2, we have XY is congruent to ZW and ZW is congruent to AB, then XY has to be congruent to AB. This is the train. We start at XY, we go to ZW, we go from ZW to AB, so we went from XY to AB. This is the train transitive property. On number 3, we have angle A is congruent to angle B, and angle A is also congruent to angle C. So angle B is congruent to angle C. Keep in mind, this is written backwards. So if we were to flip this around, we have measure of B, B to A, and A to C would be angle B is congruent to angle C. This is the transitive property in disguise. Looking at number 4, let's start with what we have in the beginning. AB minus BC equals 7. Now the second statement they've given us has AB all alone. So how we would get AB all alone is we would add BC to both sides. On the left, we would have AB, and on the right, we would have 7 plus BC. So what we did is we added the same number to both sides. So this would be the addition property of equality. And you can go ahead and start writing POE for property of equality. It's just a shortcut so you don't have to write so much. On number 5, we have measure of angle A plus the measure of angle B equals 92. And the measure of angle A is 61. Since the measure of angle A is equal to 61, we can substitute 61 in for A. And that's what is done here. 61 plus measure of angle B equals 92. This would be the substitution property. On number 6, I can use one of 2 different properties. If I were to take 1/2 and it's times by x, I would do the opposite, which is divide both sides by 1/2. The 1/2 and 1/2 cancel. I have an x on the left. This right here is a division sign. With that division sign, I'm dividing some fractions. So I can copy the first number, change the divide to a times, and flip the second one. Copy dot flip. That's how we divide fractions. And 5 times 2 is 10. This we divided. This would be the division property of equality. I could also use the multiplication property of equality here if I times both sides by 2. The 2 and 1 cancel to leave me an x on the left, and 5 times 2 is 10. This would be the multiplication property of equality.